Okay, when you have petrofilm, well, I have some sample here. Let's look at you, easiest one. The APC. Okay, that's the APC. So we go over the petrofilm. This is the APCs. Now, how do we know it is APCs? You see it's a red colony, is that right? So that is pink, red colony. Can somebody count how many it is? You need to find your highest dilution. How many it is? Yahaya, can you go ahead and count one? No, not the top one, the bottom one. How many it is? You should have 10 to the 6, is that right? 10 to the 4 and 10 to the 2. This is probably 0, is that right? Did anybody who get some there? 10 to the 6, did you get some?
I got one.
Oh, you have one.
I got one.
Who got some?
I got one.
You got one, okay. But basically you get one. So this one we're not going to use. It's too less. Is that right? It's not belonging 30 to 300. How about the 10 to the 4th? Somebody can give me a number?
97.
200.
97.
297.
Yeah, sure. 297.
Okay, good. That's good. That's a good example. 297. Okay. Then this is obviously is TNTC, is that right? Too numerable to count. Okay, let's just give an example. How many bacteria there? Then 297 multiplied by 10 to the 4. 297 multiplied by 10 to the 6. How many it is? This is probably around 6.5 log 10 CFU per ml of our pound water. Is that good? Obviously it's not good. That's too much. And I said that 5 log is a bottom line. Is that right? You cannot pass 5 log. So that's not drinkable. Okay, it's too much. Okay, so that's something we want to mention about here. Okay, now second one, look at you. Coliform and the E. coli petrifilm. What looks like? Okay, I have some sample. I find this one is 1, 2, 3, 4, 4 colony for coliform. There is no E. coli here. Did anybody find the E. coli there? Yeah, look at your sample. I think that's a good one. To be honest, that's a good one. Yes, that's a pretty good one. How many colonies are there? So what you find there, basically what you find is those red one. Okay, this is coliform. Did you see any of you have these? Gas and the blue one. Then this will be E. coli. Do you have it? How many you have?
I have 42 of these.
Okay, good. 42, what's the dilution factor? 10 to the 2?
10 to the 4th.
10 to the 1? How many?
4. 10 to the 4th.
Okay, 10 to the 4. That's a lot. 10 to the 4, that means 4.2 multiplied by 10 to the 5. That's almost 5.7 log 10 CFU per ml. That's a lot of coliform there. Did anybody see E. coli there? Okay, then that's fine. That's not too bad. At least there is no direct indication the pond water near our campus, which is contaminated with the poops, with the animal or human poops. That's not too bad. Because there the coliform could be everywhere, okay, because it's near the hospital. Not too bad. So that's what we do the counting for the petrofilm. So just want you to get some experiences, okay? Okay, today's work we will do is Kirby blood test for antibiotic resistant. This is what we talk in the lecture. We haven't practiced yet. And I also want to bring these. The fact sheets we'll give to you later because the printer is not good today. Okay, what we need several items right here. Basically, is an agar, a bacterial solution, cotton swab, dispenser, and don't forget we need these discs. There is containing antibiotics. Okay, so this is what we're going to do today. Is Kirby Beau test of antibiotic resistant. Okay, so first of all, very quick to review what is antibiotics. It's a metabolic chemicals generated from one microorganism to kill or inhibit another microorganism. And most of the time we say kill is bactericidal. And we say inhibit is static. And I said most of the time this one microorganism is fungi. And this microorganism killed or inhibited is most of the times bacteria. Okay? So we're going to jump into how we're going to do it. First of all, there is a standard to know how many bacterial solution there. It does not mean anything you can just take it out to do the test. Bacterial solution needs to reach 0.5 McFarland standard. This is roughly 10 to the 8th cells per ml. There is a silicone sample. You can do a comparison, which is turbidity. We don't have it. It's expensive. This bacteria growing here most likely is 10 to the 8th cells. Obviously, you need a shake. Okay, before you do E. coli and the Staphylococcus aureus, you need a shake because most of them are at the bottom. So this is the first thing first. Second, we will need agar plates. I'll need to draw a little bit large. This is too small. This agar plate is huge. Not really huge, it's still normal one, but needs to be a little bit large. This is a molar Hilton agar. It's not nutrient broth agar or like trapped soil agar, specifically for antibiotic resistant. What are we going to do first? Obviously, you're going to add a bacteria there, is that right? So, cotton swab is right here. So, take out one cotton swab. And then, goes here to add the bacteria. How you add it? Very gentle. To do like this. Very gentle. To do vertical swab. Very, very gentle. Try to cover the surface as much as you can. Then turn 90 degrees. Do a second one. Okay, same thing. Like this. Very gentle. Okay, then what we do? Then you come here or you come to TA, we're going to have two groups. You will to do gram-positive bacteria. We using, now of course we're going to add the bacteria, we add gram-positive bacteria, Staphylococcus aureus. Gram-negative bacteria, using E. coli. Okay? So everybody going to do two bacteria. Now obviously you have the label at the bottom, okay? It's E. coli, you name, batch number, those are the same thing. When you add Staphylococcus aureus there, when you add E. coli there, then we use a dispenser. These have to be put in there first. Then we press the button. These discs will be dropped onto the surface. What are these discs for? We will do two sets. Everyone, each individual, you will do Staphylococcus aureus and E. coli. But one person will do these three, which is chlorophynical, the first one. Okay? I'll just write CL, chlorophynical. So what's the concentration? Usually these concentrations, they wrote there. We need to find is 30 microgram. Chlorophynical. The second one, tetracycline. TE. TE is an acronym for tetracycline, and the concentration is 30. Still 30 microliter. Okay, another one we were doing is tetracycline. This is tetracycline, this one is chlamydia. We'll do kanamycin. Kanamycin will be K, also is 30. So 3 discs will be there. These discs you need to know. This is acronym of a bacteria. Sorry, it's antibiotics. And this is the concentration. The concentration most of the time is 30 microgram or 10 microgram, depends on the standards. The standard is from American Antibiotic Clinical Association. Okay, once you do this, what we do? Use your forceps or your loop to press a little bit. Just press a little bit, okay? Don't press too hard. Then we will incubate 35 degrees Celsius at 24 hours. And after that, what you're gonna see? You will see a transparent zone surrounded. Some of them are large. Some of them may not have. Some of them are huge. Maybe like this. A transparent zone. Now what we do, we're going to use a ruler to measure the diameter. The diameter has to compare a standard. So for example, if this is tetracycline, we measured 20 millimeter. For example, okay, just an example. So you're going to look at the table. The table I'll give you on Thursday. Okay, we have a 3 level. You have a 20 millimeter right here. I have a susceptible, resistant, and intermediate right in the middle. Okay, so let's say susceptible 16, intermediate 12, resistant 8. If you get 20, what this means? It's susceptible. That means this E. coli or this Staphylococcus aureus is susceptible to 30 microgram per ml, basically 30 ppm tetracycline. Okay? Let's say if I get 5 ml, then what this means? It's resistant because it's less than 8 millimeter. So this E. coli or Staphylococcus aureus is resistant to 30 microgram tetracycline. Which means this patient, if it's a clinical trial, this patient cannot use tetracycline. Because otherwise it's going to generate, it's not going to have any impacts. But so be careful, although you see the inhibitory zone more or less, the size will be determined by the table, whether it is susceptible, intermediate, or resistant. Here we don't say sensitive. The reason is that some of the people is allergic to penicillin. So before you do penicillin muscle injection in the old time, they have to do the skin test. At this moment, we say this person is sensitive to penicillin. So the antibiotic sensitive, we basically say the patient is allergic to certain antibiotics. Okay? For bacteria, we use the name is susceptible. Okay? So we can go ahead to do that. Now I'm going to also tell you, we have another set of the three antibiotics, which is penicillin, which is that's going to be 10 microliter only. So that's penicillin. The second one what we have is tetracycline also. Streptomycin is S10. Okay. Another one right here, let's see. Streptomycin, penicillin, and also that's tetracycline. So that's tetracycline is the same thing. It's 30. So this is what we're going to do. Everybody grab 2 molar Halton agar. Using cotton swab to inoculate Staphylococcus aureus, another one is E. coli. Then you come to the front. One of you, we will be dispensing chlorophenicol, caramel and tetracycline on your 2 plates. Then you bench partner, we will dispense penicillin, streptomycin, and tetracycline. Okay? Then you can do the comparison. The gram-positive bacteria and the gram-negative bacteria, is there any difference? So go ahead to grab molar Halton agar and the culture, and we're going to go ahead to help you to do that.